Okay, so let's look at some examples for week 9. So let's do 28 in our book. Although studies continue to show smoking leads to significant health problems, 20% of adults in the United States smoke. Consider a group of 250 adults. A, what is the expected number of adults who smoke? B, what is the probability that fewer than 40 smoke? C, what is the probability that from 55 to 60 smoke? And D, what is the probability that 70 or more smoke? So the values we can get are N is 250 because we have 250 adults. Whoa. The P with the proportion is 20%, so that's going to be 0.2. Now, mu is going to be equal to N times P is going to be one equation for the expected value. And then our variance is going to be N times P times 1 minus P. So what is the expected number of adults who smoke? Well, it's just going to be N times P. So that's 250 times 0.2, and that's 50. Now, what is the probability that fewer than 40 smoke? Well, first we have to find our variance, and then after that, our standard deviation, and then we can go from there. So variance is going to be the N times P times the 1 minus P, so 250 times 0.20 times the 1 minus 0.20, that's 40. Now, to find the standard deviation, that's going to be 40 to the 1 half, which is 6.3246. Now, allowing for the continuity correction factor, because this is continuous um, distribution, we can't just find a value for exactly one number. And so we're going to use the correction factor. You can read about it a little bit more on page 284. And so we're going to, instead of it's going to be probability x is less than 40, but we're going to say actually looking for x as less than or equal to 39.5. So looking at that 39.5, we plug it into our z equations. So x is going to be 39.5 minus 50, which is our mu we found up here, divided by our sigma, which we found right here. And so we have negative 1.66 is the value we get for z. Now, if we look that up in the z table, that gives us the probability x less than or equal to 39.5 is 0.0485. So that's the probability that fewer than 40 smoke. Now, what is the probability that from 55 to 60 smoke? Well, again, we're going to allow for that continuity correction factor, and instead of 55 to 60, we're going to go 54.5 to 60.5, and so we need to use those values in our z equation. And so 54.5 minus 50 divided by 6.3246 gives us 0.71. Looking that up, we get a probability of 0.7611. At 60.5, we end up with 1.66 after we plug it in the same equation, and that gives us a probability of 0.9515. Now let's think about these. What did that mean on our graph here? So if we draw the normal curve, 50 is our mean, 54.5 was one item, 60.5 was the upper, and we want to find this value in between. Now remember, at the 54.5, the probability is basically everything from that line to the left, and at the 60.5, the probability is from everything from that line to the left. And if we want to find that dotted space in between, we just take the larger minus the smaller. And so that's what we do to find that probability that x is between 54.5 and 60.5. We just take the larger, the 0.9515, subtract the 0.7611, and we get 0.1904 for our probability that is between those. Now, once again, for part D, what is the probability that 70 or more smoke? Well, we can't find it for exactly 70, but let's go for 69.5. So we plug that in, we get 3.08. Now, the probability in the table is going to be off the charts. So the highest number in the table is 0.9990, and that's our max value because it really only goes up to 3.0. So that's going to be basically that. And so greater than that value is going to be 1 minus the 0.990, and that's going to be 0.001. Okay, and some books, some tables, you might end up giving this to be a value of just 0 because there's not going to be a probability it's going to be greater than that 3.08. So it all kind of depends on if you're using the table or you're using actual values. All right, next one. Comcast Corporation is the largest cable television company, the second largest internet service provider, and the fourth largest telephone service provider in the US. Generally known for quality and reliable service, the company periodically experiences unexpected service interruptions. On January 14, 2009, such an interruption occurred for the Comcast customers living in Southwest Florida. When customers called the Comcast office, a recorded message told them that the company was aware of the service outage and that it was anticipated that service would be restored in 2 hours. So we're going to assume that 2 hours is the mean time to do the repair, and that the repair time has an exponential probability distribution. So we want to find out A, what is the probability that the cable service will be repaired in 1 hour or less? B, what is the probability that the repair will take between 1 hour and 2 hours? And C, for a customer who calls the Comcast office at 1 p.m., what is the probability that the cable service will not be repaired by 5 p.m.? Okay, so let's first, what is the probability it will be repaired in 1 hour or less? Okay, well, first we need to have our equations we're going to use. So we're going to use exponential probability density function. So f of x equals 1 over mu e to the minus x over mu for x greater than or equal to 0. And mu is the expected value or the mean. And they said that was going to be 2 hours in our case. So that's going to be this value here. The exponential distribution for cumulative probabilities. So the probability x less than or equal to x naught is 1 minus e to the negative x naught divided by mu. So our first question was to find the probability of the cable service repaired in 1 hour or less. So first, with our mu equals to 2, we can get the probability density function, plug in 2 for mu, and we have that. Now, if we want to have the probability is less than or equal to 1, now we can use this equation. So we have 1 minus e to the minus 1 over 2. And basically what we use this for is kind of make sure we know that the mu is 2. And so we plug that into our calculator, and we get 0.3935 for the probability x is less than or equal to 1. Now the next one is going to be between 1 and 2 hours. Well, we already know that less than or equal to 1 hour, so we know part of our curve. But less than or equal to 2, we need to plug the 2 in instead of the 1 up here. So we plug the 2 in, solve it with our calculator, we get 0.6321. And now we're going to take the larger minus the smaller, and so 0.6321 minus the 0.3935 gives us 0.2386, and that's for the probability that's going to be between 1 and 2 hours. Okay. Now the other one was it's going to be greater than 4 hours. Well, if you remember, we can do the 1 minus the probability. It's going to be less than or equal to 4 hours. And then we can use our equation up here. And 1 minus e to the negative 4 over 2. We plug that whole thing into our calculator. Really, it just becomes e to the minus 2 because the 1's cancel. Minus 4 over 2 becomes minus 2. And so we just get 0.1353 is the probability that it's going to take more than 4 hours. Now, number 42 in our book says, during early 2012, economic hardship was stretching the limits of France's welfare system. One indicator of the level of hardship was the increase in the number of people bringing items to a Paris pawnbroker. The number of people bringing items to the pawnbroker had increased to 658 per day. Assume the number of people bringing items to the pawn shop per day in 2012 is normally distributed with a mean of 658. So for question A, it says, suppose you learn that on 3% of the days, 610 or fewer people brought items to the pawn shop. What is the standard deviation of the number of people bringing items to the pawn shop per day? B, on any given day, what is the probability that between 600 and 700 people bring items to the pawn shop? And C, how many people bring items to the pawn shop on the busiest 3% of days? So that 3% is going to be kind of our probability we need to look up in our table. 658 is going to be our mean. So probability of 0.03 in our table gives us a z-score of roughly negative 1.88 for the lower tail. So if we plug that all into our z equation, we can find the sigma, because we were given at 610 days, 658, or people, I mean not days, 610 people, 658 was the mean, and negative 1.88 was from our percent, which gave us the probability, or the z-score of negative 1.88. So if we solve this equation for sigma, we get 25.5319 for sigma. Now, B, we want to look between 600 and 700 people. Okay, so really this is kind of what we're doing here. We know 600's over here, our mean was 658, 700's here. So what we know is we're going to do that 700 minus the 600 again to find that value for probability between the two. So we plug in x is 600, into our z equation. So 600 minus 658 divided by our sigma, that gives us a negative 2.31, and that probability is 0.0104 in our table. And 700, we plug that in, we get 1.65. That gives us 0.9505 in the table. Now, the probability that it's between 600 and 700 is just the probability. Is z is between negative 2.31 and 1.65, or taking that subtraction, we get 0.9401 is that probability. Now, see, well, how many people bring items to the pawn shop on the busiest 3% of days? Okay, so the busiest 3%, that's going to be out here. So we want the positive 1.88 instead of the negative 1.88. And so we plug all that into our z equation again. Now we've solved it for x, so we just plug in what we know. We know mu is 658, z is 1.88, and our sigma is 25.5319. Simplify that, we get 706 people. So on the busiest 3% of days, 706 or more people show up at the pawn shop. All right, number 46. Assume that the test scores from a college admission test are normally distributed with a mean of 450 and a standard deviation of 100. A, what percentage of the people taking the test score between 400 and 500? B, suppose someone receives a score of 630. What percentage of the people taking the test score better? What percentage score worse? And see, if a particular university will not admit anyone scoring below 480, what percentage of the persons taking the test would be acceptable to the university? So what our one going to do first is between 400 and 500, mu is 450, and sigma is 100. So we plug that into z. 400 minus 450 divided by 100 is a negative 0.5. So that gives us, well, actually that's not a z of point, that should be a probability there. Just type that. And so that's our probability. And at 500, we plug that in, we get 0.5. So that's actually the z here. And so then the z will give us a probability of 0.6915. And so the probability between 400 and 500, well, here's our mean. 400's here, 500's here. So we have to take the larger minus the smaller, and that gives us 0.3830 as the probability. So what does that tell us? Well, that tells us 38.3% of the people will score between 400 and 500. Now for B, it said, what about the 630? What will score better and what percent will score worse? So at 630, we get 1.8. And again, this is the probability, not the z. That's 0.9641. And so what does that say? Well, at 630, that's way over here, and it's going to be the value all the way down here. So that means worse is going to be below that. So 96.41% will do worse, and only 3.59% is actually going to do better than that 630 value. Now the final one, they will not admit anyone scoring below 480. So we need to look at what 480 does. So 480 minus the 450 divided by 100, that gives us a 0.3. And that's the probability, not the z again, of 0.6179. Okay, so that's going to be 480, so that's going to be somewhere about here. So that's going to be the score down below. So 61.79% of the people are not going to get in, but 38.21% are acceptable. That's going to be above that 480. And this is going to be the last one I do for tonight. The website of the Bed and Breakfast Inns of North America gets approximately 7 visitors per minute. Suppose the number of website visitors per minute follows the Poisson probability distribution. A, what is the mean time between visits to the website? B, show the exponential probability density function for the time between website visits. C, what is the probability no one will access the website in a 1-minute period? And D, what is the probability no one will access the website in a 12-second period? All right, so we're going to use our exponential probability density function and the exponential distribution again. And so what do we know? The first question was, what is the mean times per arrival? Well, it said that there were 7 visitors per minute. So that's going to be the 1/7. I typed that wrong, but it's the answer is 1/7. So it's 1 1 minute and 7 visitors. So we're trying to break it up there. And so that's 1/7. So I should really watch what I'm writing here when I'm typing. I guess it's because it's late at night. I guess it's not going to let me type either. So kind of ignore the visitors and the minutes here. I was reading it wrong when I was writing it. So it's 7 visitors per minute. So it's 1 minute per 7 visitors. So we're going to make that into 1/7. That's the mean time between arrivals. Now we have to plug that into this function up here. So 1/7 goes for mu in both places. So 1 over 1/7, that becomes 7. And here again, it becomes 7. So we have a minus 7x. And so that's going to be our probability density function. Now we want to know what is the probability no one will access the website in a 1 minute period. So we want to know greater than 1. So that's going to be the same as 1 minus the probability it's less than 1. And so we can plug everything in here. So we plug in the 1 up here for x, 1 minus the 1, that's going to be 0. And then we have a negative times a negative is positive, so we just have e to the negative 7, and if we plug that in our calculator, we get 0.0009. Now 12 seconds, how much of a minute is that? Well, that's 12 divided by 60, so that's going to be 0.2 minutes. And again, it was greater than 0.2, so we do the 1 minus the x is less than 0.2. And we simplify that, and basically all we have is e to the minus 1.4, which gives us a 0.2466 probability that no one accessed the website in a 12-second period. Okay, so very small number for no one will access the website in a 1 minute period. Little bit higher probability that they won't access it in a 12-second period. All right, so sorry for the mistake up here for the visitors and minutes, as well as over here. These are not z-scores. These are probabilities actually. So I have to pay attention to what I'm writing down and not always write what I'm thinking or not thinking, I guess. So hopefully that will help this week. And if you have any questions, please email me. Thank you.